In this concept, we're going to talk about the quadratic function. So a quadratic function is a function that is described by the following equation form. Okay? F of x, which is the function, is equal to ax squared plus bx plus c, where ax squared is identified as a quadratic term, meaning the exponent of x is 2. The largest exponent out of any term of the terms of the function is 2. And then plus bx, this is a linear term, right? Because the exponent of x is 1. Okay? Plus c, which is a constant term, just a single constant. Where a cannot be equal to 0. Because what would happen if a were 0? So if a were 0, you would not have, the quadratic term would be non-existent, right? So it would vanish to 0, and then it would not be a quadratic function, it would be a linear function, because the linear term would be the term with the largest exponent. So that's why a cannot be 0. You can have b and c equal to 0. For example, you can have f of x, equals x squared. That's it, right? No x term and no constant term. This would still be considered a quadratic function, as long as a is not equal to 0. In this case, a would be 1. Okay? So the graph of a quadratic function is called a parabola, as shown in this figure. You should have seen this before. Okay? So a parabola is a shape that has different properties that we're going to discuss. So one property is called the axis of symmetry of the parabola, and that is the line that divides the parabola such that the two sides would match each other. The two sides of the parabola would match each other. They would be mirror images of each other. So in this picture, this is the axis of symmetry. And as you can see, it cuts or breaks the parabola curve into two identical parts, right? This is one part, and then this is the other part, right? And these two are mirror images of each other along the axis of symmetry. Another feature of the parabola graph is the y-intercept, and that's the point where the graph of the function intersects the y-axis. In this case, this is our y-intercept, right? Where the parabola intersects the y-axis, and this is the x-axis, right? This is plus y, this is minus y. Okay, the vertex is the point at which the axis of symmetry intersects the parabola. So the axis of symmetry breaks, as we said, breaks the graph into two equal parts. There's a point where the axis of symmetry actually crosses the parabola, and this is where the vertex is. Yet another feature is the x-intercepts. And the x-intercepts are basically the solutions of the equation, right? Once you solve for x, typically you'll get two numbers, right? And these are the numbers when the y value of the function is equal to 0, meaning you're on the y-axis. I'm sorry, when the x is equal to 0. When the y is equal to 0, right? So you're on the x-axis, and these are the solutions. And these are where the function crosses the x-axis, right? These are the x-intercepts. Now, the axis of symmetry can be determined using this equation. So x equals minus b over 2a. So you just take the value for b, which is the coefficient of the linear term, minus b over 2a, a being the coefficient of the quadratic term. And then you have the equation of the line, which is the axis of symmetry. It's essentially going to have, the equation is just going to have the form x equals, some constant, right? Which is minus b over 2a, whatever that value comes out to be. So it is going to be a vertical line. Okay. Now, the vertex lies on the axis of symmetry, whose x value is the x-coordinate of the vertex. So the vertex is some point that's going to have coordinates, x of the vertex and y of the vertex, right? So x of the vertex is essentially the same as the equation for the axis of symmetry, right? So let's say the axis of symmetry, we're at x equals 3, right? So it's going to be a line at x equals plus 3, right? This would be an axis of symmetry. The x-coordinate of the vertex is going to be 3, so the vertex is going to be somewhere here along this line in x. To find the y, the corresponding y-coordinate of the vertex, we can plug in this x value into the equation, the quadratic equation for the parabola at hand. And then we would have a y-coordinate for the vertex. So then if we have an x and y for the vertex, we can just plot it, right? X vertex and y vertex. Okay? So another feature of the y-coordinate of the vertex is that it can be either a minimum or a maximum value. It has to be either a minimum or a maximum value, right? So let's say, in this case, this parabola opens up. So the vertex is the minimum value of this function. There is no other value on the function that is smaller than the y value of this vertex. Okay? Let's say you had a parabola that opens down, not up. In which case, well, this is not too good looking. Let's do this. Yep. So in which case, this vertex is the maximum value for the function. Okay? There is no other value on the function graph that is greater in y than the y value of this vertex. And this is summarized here, right? So if a, and this is all determined by a, which is the coefficient of the quadratic term. So remember, right, f of x equals ax squared plus bx plus c, right? Remember the equation form. So if a is greater than 0, if a is positive, if the coefficient of the quadratic term is positive, the parabola opens upward. And the vertex is a minimum value, just like we had here, right? If a is less than 0, right, if a is negative, the parabola opens downward and the vertex is a maximum value, just like we have here. Okay, so please keep this in mind. Let's look at some examples. Graph the function f of x equals x squared minus 2x minus 24. So first, check whether the parabola opens upward or downward by testing the value of a being, again, the coefficient of the quadratic term, right? For this function, a is equal to 1. So right here, a is equal to 1. Thus, the function opens upward. So we know it's going to have, this form, right? It's going to open up. Okay? Second, find the axis of symmetry. The axis of symmetry of a parabola is x equals minus b over 2a, like we've discussed earlier. So plug in the values for b. B in this case is minus 2, right? Minus 2. And a is equal to 1. So plug those in, minus b over 2a, and the x-coordinate of the vertex, you get 1. To get the y-coordinate of the vertex, we need to find the corresponding y-coordinate by plugging the x equals 1 in the equation, right? Keep in mind, the vertex is a point on the graph of the function. So once you found the x value of the vertex, you can plug in that x value to get the y value, right? And it has to be on the function, by definition. Plugging in 1 in our f of x, we get f of 1 is equal to 1 squared minus 2 times 1 minus 24. So 1 squared minus 2 times 1 minus 24, which gives us minus 25. So the vertex point, the coordinates for the vertex are 1 and minus 25. Okay, so now we have the vertex. Then we can find the x-intercepts of the function, right? Intercepts. By setting the function equal to 0. So we need to find the x's when y is equal to 0. So far, we have this, right? We have, let's do 5, 10, 20, 25, minus 5, minus 10, minus 20, minus 25. Okay? So our vertex is at 1 and minus 25. So our vertex is somewhere here. Okay? And we know it opens up, right? The parabola opens up, so it's gonna look something like this, right? But we don't know how wide. Does it look like this, or does it look like this? Or does it look like this? Well, we don't know how wide it opens, but that's what we're going to determine by determining the x-intercepts, right? Because then we can figure out how wide it's going to open and where it's going to cross, the x-axis on both sides, right? So that's what we're trying to determine by finding the x-intercepts. So again, setting f of x equal to 0, we'll get, so 0 equals x squared minus 2x minus 24. We factor this, just like we factor polynomials, like we've learned in a previous concept. You'll get x squared, and so x squared factors to x, and then minus 24 will have factors, again, 24 times 1, or 12 times 2, or 8 times 3, or 6 times 4, etc., etc. Now we need two factors that, when added or subtracted somehow, and give us minus 2. So 24 and 1 don't work, 12 and 2 don't work, there's no way they'll give us minus 2, 8 and 3 don't work, 6 and 4 do work. There is a way to add or subtract 6 and 4 to get minus 2. Okay? And what is that way? So if we had minus 6 plus 4, that gives us minus 2, right? So we have x minus 6 and x plus 4, right? Such that we get it, if we added them, we get a middle term of minus 2. Okay? So plus 4x and then minus 6x, which is minus 6 plus 4, or plus 4 minus 6, gives us minus 2. So these are our two parentheses, and then when we solve each of these for 0, right, we get two equations. We solve each of them, we get x equals minus 4 or x equals 6. So remember, for the or operand, you have to take both solutions, right? So both of these are valid. Both of them are valid. So these are essentially our x-intercepts, right? So minus 4 will be, so, minus 5, plus 5, etc. So minus 4 is somewhere here, and plus 6 is somewhere here. So this is what our parabola looks like. Well, forgive my drawing, but there you go. It'll do this, and then it'll curve like this and do this. So it's a very narrow parabola, but this is an accurate representation of what it should look like. Okay? We could have also found the y-intercept. In fact, we should, for the most accurate representation, we should know what the y-intercept is, and that's actually easier to determine, right? So you find the y-intercept by setting the x is equal to 0. So in this case, we'll have, so x squared goes to 0, minus 2x goes to 0, so the y-intercept is equal to minus 24. So this is actually minus 24. So this, this does this. Oops. We lost everything. Yeah, so this is minus 25, minus 24, right? So it crosses the y-axis like this. Okay, and then it curves here, and then it goes back up. So a very narrow parabola. Okay. Let's look at another quick example. And this has to do with testing for a minimum or maximum value. So does the function f of x equals x squared minus 3x plus 8 have a maximum or a minimum value? Again, remember that having a maximum or minimum value depends on the coefficient of the quadratic term. If it is a positive coefficient, if it is a positive number, right, here it's plus 1, then the function has a maximum value, right? So since a is greater than 0, then the graph opens up and has it has a minimum value. So if the graph opens up, right, if it opens up, then the vertex is all the way down, so the vertex is a minimum. If the graph opens down, then the vertex is all the way up, and it happens to be the maximum for the graph, for the curve. Okay? Very good. So here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, let's look at this first exercise. Which of the following is the graph of y plus 1 equals x plus 1 squared? So first off, you'll notice that we have two curves that open up and two curves that open down. So here's a quick trick. Let's try to eliminate half of these, right, by determining whether the graph opens up or down. And how do we do that? Again, we test for the coefficient of the quadratic term. Now this is an odd looking form, right? You're used to having, or we learned the quadratic equation in this form, right? So ax squared plus bx plus c, right? Or f of x, you could say y instead of f of x, right? But here we have this form. But this should not be difficult to convert to this form, right? So what are we going to have? So we'll have y plus 1 equals, so how do you expand x plus 1 all squared? So we'll have first term squared, x squared, plus first term times second term times 2, which is 2 times x times 1, which is 2x, plus the last term squared, right? 1 squared is 1. And then y plus 1, we can subtract 1 from both sides, which will give us y equals x squared plus 2x, right? And these two will cancel out. So this is our equation in the standard quadratic equation form, right? So essentially you'll see that a is equal to 1, b is equal to plus 2, and c is actually equal to 0. Now let's test the coefficient of the quadratic term to see whether the function opens up or down. So a, in our case, is plus 1. So since it's positive, we know the function opens up. Okay, so this automatically eliminates b and c, right? Because these functions open down. So our choices are either a or d. I'm trying to, right? What's another quick test that we could do to determine which is the right answer? So let's look at the vertex, right? We are given the vertex, the location of the vertex. So the equation, or the x value for the vertex, can be determined by finding the line of symmetry, right? Which has an x value of x equals minus b over 2a. So minus b is minus 2 over 2 times a being 1. So minus 2 over 2 is minus 1. So the vertex is located at, the x value of the vertex is located at x equals minus 1. So for choice A, the vertex is at 1 and 1. X value of the vertex is 1, not minus 1. So choice A is not what we want. Choice D, the x value of the vertex is at minus 1. So choice D is the answer. Okay? Let's look at the next exercise. Graph this function. State whether the function has a minimum or a maximum value. So first off, we'll see that a is equal to minus 1. Okay? And since a is less than 0, it's negative, therefore the graph opens down, or will have to open down, right? And the vertex will be a maximum value. Okay? So this part we're done with. And now to graph the function, let's just list out b and c. So b is plus 4, c is minus 3. So the first step, again, determine the vertex, determine the line of symmetry, then the y-coordinate of the vertex. So the line of symmetry is at x equals minus b over 2a. So that's equal to minus 4 over 2 times negative 1, which is equal to 4 divided by 2 is 2. So the x value of the vertex is 2. Okay? If we take the 2 and plug it in to the equation, so y equals minus 2 squared plus 4 times 2 minus 3, we get 2 squared is 4, so minus 4 plus 8 minus 3. So this gives us minus 4 plus 8 is plus 4, minus 3 is 1. So this gives us y of the vertex is equal to 1. Right? So the vertex is at 2 and 1. Then we would have to find the x-intercepts and the y-intercept, just to be more accurate. So for the, let's draw a line here so we're a little more organized. So for the x-intercepts, what we do is we just set it equal to 0. So y equals so 0 equals minus x squared plus 4x minus 3. So we need to factor this. However, the a, the coefficient of the quadratic term, is negative. So to make things easier, we'll just factor out a negative 1 from all these terms. So we'll have like negative 1 essentially times x squared minus 4x plus 3 equal to 0, right? So we have two parentheses now, the negative 1 and then this expression. So this expression should equal 0. Or said another way, we could just say multiply both sides by the negative 1 to get rid of the negative 1 and to simplify this expression further. So 0 times negative 1 is still 0. this whole expression, this whole thing, the 2 parentheses times -1, does away with the -1s, and I get the second parentheses, the second pair of parentheses. So this is equal to x squared minus 4x plus 3. Factor this further, just like we've learned in a prior concept. Again, this is where the factorization comes into play. So x and x, so you have plus 3 only factors out to 3 and 1. Since this is plus and this is minus, so we'll have 2 minuses, right? Okay, so this is how this is factored. So x minus 3 equals 0, gives us x equals 3, x minus 1 equals 0, x equals 1. So our x-intercepts are 3 and 1, or 1 and 3. We can very easily find the y-intercept by plugging in 0 for the x's, so y equals minus 0 squared plus 4 times 0 minus 3, so minus 0 squared is 0, plus 4 times 0 is 0, minus 3, so y equals minus 3. So the y-intercept is minus 3, and the x-intercepts are 1 and 3, and the vertex is at 2 and 1. Look at that. So we have all the information we need to graph a nice-looking parabola for our equation. So let's draw our coordinate plane, and we'll put the vertex at 1, 2, and then 1, right? This is our vertex. And then the x-intercepts are at 3 and 1. So this is 3, and this is 1. And then the y-intercept is at minus 3. So minus 1, minus 2, and minus 3. So this is the y-intercept, and these are the two x-intercepts, and this is the vertex. And then just graph our equation just like that. And on the other side also. Oops. So just like this. And there you go. Vertex, y-intercepts, x-intercept. Okay, hopefully this was clear. This is it for this concept. See you in the next video.